Hello everyone, welcome to our presentation in IEEE SMC Conference 2021. My name is Huang Yan Pei. I'm from Human Robotics Group at Imperial College. The topic of this presentation is Trimanipulation, evaluation of human performance in a three-handed coordination task. Let us start with some background. Many augmentation devices, like a supernumerary robotic finger, robotic arm and legs, are developed to extend human motion capability. When this augmentation increases the number of movement degrees of freedom, it can enable a person to perform tasks that are impossible to perform with their natural hands alone. The supernumerary robotic limb can be controlled using three forms of interfaces. Muscle interface pick up muscle activity to command the supernumerary limb. Neutral interface extract signals from the nervous system. Body interface use measured movement or force of a body segment. Among all these three types of interfaces, body interface are in general non-invasive and easy to learn. They may use information coming from head, finger, foot, or eye gaze. The use of foot motion to control a third hand is an attractive option due to the foot's ability to control multiple degree freedoms and its relative independence from humans' natural hands. While the coordination between the supernumerary limb and the natural limbs could be identified based upon whether the limbs have to work together to achieve a task and whether there is any physical or virtual linkage between the limbs. The table shown in the red summarizes the coordination in the case of manipulation with three limbs. Some recent studies evaluated human augmentation performance based on this taxonomy. They have found that without the presence of physical constraint, superior performance is possible using three hands in place of two. When comparing subject performance to that of dyed persons, the dyed still outperformed the single user controlling the supernumerary limb. However, it is still unknown how the human behave and learn about controlling a supernumerary robotic limb in coordination with their natural hands. Therefore, in this study, we investigated human performance in three-hand coordination tasks with an additional hand controlled by foot. We mainly studied the learning of trimanipulation in a three-hand coordination task. We compared the user's performance of one person controlling three hands and two persons' cooperation. And we also studied the effect of an unpredictable environment on the trimanipulation. To achieve this, we had an experimental study with 14 participants. The experiment was conducted using a teleoperation system with two hand interfaces, one foot interface, and a virtual reality test environment. The participants were asked to control three virtual hands in 2 degree freedoms using their natural hands and the dominant foot. Virtual hand 1 and 2 were teleoperated using left hand and right hand respectively. Virtual hand 3 were controlled by their dominant foot. This is a 2-day study. On the first day, each participant conducted a training phase and a practice phase. In the training phase, the three limbs used their respective hand-foot interface to control a single virtual hand one by one. A single target was shown on the screen, and one of 3 virtual hands were used to reach the target. This phase was designed to help the participants understand the mapping and control scheme. After the training phase, the subjects were asked to control the 3 virtual hands together and practice the trimanual task. 10 sessions of totally 200 trials were conducted in this phase. Between sessions, each subject was given 30 seconds to rest. This trimanual task simulated a 3-hand coordination scenario. It was designed to simulate everyday activities requiring physical coordination of each hand. For example, holding a tray or case when assembling furniture. In the task, An elastic triangle object was held by 3 virtual hands, and its center of mass controlled by the coordinated movement of 3 virtual hands. Haptic feedback was provided to the hands for rendering the elastic force. The participants were asked to maintain the length of 3 elastic edges within a set range and to move the center of mass to the target. Then on the second day, the subjects conducted the test phase, which was the same as the practice, and the reference phase, in which 2 subjects were paired to perform the same trimanual task in 10 sessions. One operator used their natural hands and their partner used their dominant foot to cooperatively perform the task. Randomly, half of the subjects performed the test phase first and the other half the reference phase first. Then in the assessment phase, the subjects finally filled assessment questionnaires. In addition, to study the sensitivity of trimanual and diet cooperation to a dynamic environment, we separated subjects into 2 groups, with a fixed or random ordering of the same targets. In the fixed group, every session had the same 20 targets with a fixed order in all phases, while in the random group, the targets were shown in an unpredictable sequence. 8 of the 14 participants used the fixed target sequence, and the 6 subjects applied the random sequence. The performance of the subject was evaluated based upon different quantitative measures and subjective measures. First, we have measurement of performance in success rate, efficiency ratio, and operation time. The success rate was defined as the number of successful trials divided by the total number of trials in each session. The efficiency ratio was calculated by taking the real travel distance of the center of mass and dividing it by the straight distance to the target in successful trials. In the optimal case, the efficiency ratio is equal to 1. The operation time was the difference in time between the instant where the target was shown on the screen to the instant in which the center of mass reached the target. We also measured the coordination level of every 2 hands using the coordination error. This is the sum of the dynamic deviation of each elastic edge. For the subjective measures, we have 2 questionnaires. For the first questionnaire, each participant was asked to fill it after each control mode in the text and reference phases. This questionnaire provided evaluation of the efficiency, mental effort, control, and coordination. Then at the end of the experiment, the participants were required to fill a comparative questionnaire, which is the questionnaire 2. This questionnaire asks how the trimanipulation performed compared to the diet cooperation of 2 persons regarding the difficulty and the preference. Then let us see the result of the experiment. This slide shows the performance changes of trimanipulation in success rate, motion efficiency, and operation time in practice and test phases. The task success significantly improved with the growing trial numbers. Success at the beginning of the practice phase was significantly lower than that at the end. However, no changes in success within the test phase were detected. So it seems that the subjects improved their success rate mostly in the practice phase. The motion efficiency and operation time showed similar significant tendency. The participants improved mostly in the practice phase of day 1, but not in the test phase of day 2. The coordination of every 2 hands was also mostly improved in the practice phase and then stagnated in the test phase. Both conditions that involve the foot showed higher coordination error than the coordination between the hands. No difference was found between left-hand foot and right-hand foot combinations. In addition, We compare the two operation modes of trimanual and diet control of two persons in the test and reference phases. As shown in this slide, no difference was found between the different conditions in terms of the task success rate and coordination level. However, it is interesting to find that the trimanual condition had higher motion efficiency compared to conducting the task with a partner. In contrast, the diet control still completed the task significantly faster than solo trimanipulation, controlling 3 limbs. Then let us continue to see the result of the subjective measures. The participants' response to the questionnaire 1 are shown in this slide. No significant difference was found for the time to reach the target perception and the level of control felt for the virtual hands. The participants reported significantly higher mental effort and lower coordination in 3-hand control than diet control with 2 hands together with a partner. These slides show the result of questionnaire 2 about users' response to difficulty and preference. The trimanual condition was found to be more difficult than the diet control with hands. People still preferred to achieve the task with a partner, interacting with 2 hands, than completing the task alone with 3 hands. Let us give a short summary of this work. We have explored the human capability of trimanipulation in a coordination task by using the foot to control the 3rd hand. The subjects were in general able to successfully perform the task. Throughout the practice phase of day 1, learning was clearly observed in all metrics. After the trimanual learning during the practice phase, no clear difference was observed on the success rate and coordination in the test phase and reference phase between the trimanual operation and the diet operation with 2 persons. This suggests that trimanipulation can be performed successfully by a single subject. The result also showed that after the initial learning, the trimanual condition produced a more efficient motion, while the diet operation was able to complete the task quicker. This appears to reflect the trade-off between the 2 strategies. The rankings of the questionnaire show the belief that the trimanual operation was inherently more difficult. The increased mental effort of 3-hand control may be associated with the need to plan for the 3rd hand. It is still unclear if further learning resulting in a more clear body representation of the foot being the 3rd hand. Thus, in the future, we will continue to conduct experiment study with more learning on trimanipulation and also explore how to efficiently train people to acquire this trimanipulation capability. This study is a part of the EU NEMA project, Non-Immersive Interface for Movement Augmentation project. If you are interested in it, you can find more information through the link shown in this slide. Thank you for your listening. If you have any questions, please feel free to contact me through email.